if this question says simplify, what does the word simplify mean? Yes. Make it simple. Make it shorter. Right? If you have powers with the same base, then you can apply the exponent laws, which are when the powers have the same base, if you're multiplying, you do what with the exponents? Add. And if you're dividing the powers with the same base, you subtract the exponents. Okay, so very easy. We're going to simplify the numerator first. Instead of saying x to the power of 8 times x to the power of 3, we can just write it as x to the power of what? 11. You add 8 plus 3 because brackets mean multiplication, right? So x to the power of 11 divided by x to the power of 2. Final step. This is very easy, straightforward. Now we have dividing powers with the same base. So you always write the base and then do what with the exponents? Subtract. Good. Subtract 11, take away 2 is equal to 9. That's it. What if I say now evaluate if x is equal to -2? So if I say that x is equal to -2, well, we've simplified the expression. Instead of writing x to the power of 9, what am I going to replace the x with? -2 in brackets to the power of 9. If the base is negative and the exponent is odd, what's the answer? Positive or negative? Good. What's 2 to the power of 9? Okay, 512. Okay, so you're given a question like this, and I want you to simplify first. So, make it shorter. We're going to combine powers that have the same base. You're going to put those together, right? So I have 2 to the power of 5 times 2 to the power of 3. What's a shorter way of writing 2 to the power of 5 times 2 to the power of 3? 2 to the power of 8. Good. So we've just simplified this for my numerator. And then I have 5 to the power of what? This one. Invisible. What's the invisible power? 1. Remember, every number has an exponent of 1. 5 to the power of 1 times 5 to the power of 6 is 5 to the power of 7. Does everyone know what I did there for the numerator? I'm just putting the powers together that have the same base. This power and this power have the same base, so I'm just making it shorter. Yeah. And then this power and this power have the same base, so I'm just combining them. And then I'm going to write 2 to the power of 6 underneath the 2 to the power of 8, just so it's lined up. I can visually see it and see what I'm dividing. And then 5 to the power of 5. So I've just reversed this order. When you multiply, it doesn't matter what order you write in, right? What's 3 times 4? What's 4 times 3? Doesn't matter what order you write multiplication in. But now I can see that I can simplify this even more. I have 2 to the power of 8 divided by 2 to the power of 6. So it'd be 2 to the power of 2, right? We've just 5 to the power of 2, good. So we've simplified this. That's division, right? This line means division. And then I'm doing 5 to the power of 7 divided by 5 to the power of 5 is 5 to the power of 2. I've simplified it now. I wrote the exact same thing, but I just made it smaller. Now evaluate it. You can calculate it because there's no variables. What's 2 squared? 4 times, what's 5 squared? 4 times 25 equals 100. That's the answer. So don't forget, when you have an exponent, when you have a power, it's everything in the bracket to the power of 6, right? So it's actually -1/2 to the power of 6 and x to the power of 6 and y to the power of 6. So I want you to write it out like that. It's everything in the bracket to the power of 6 because this is the base of the power. It's everything to the power of 6. Does that make sense? How do I write the denominator? It's just -1/2 to the power of 3, and then it's x to the power of what? No. 1. Good. Because we imagine an invisible exponent of 1. The x and the y in the denominator were not in the bracket. Okay, now can you simplify this? Do you have powers with the same base? Divide them. This. These have the same base, right? What's the simpler way of saying negative 1 over 2 to the power of 6 divided by negative 1 over 2 to the power of 3? What does that equal to? Negative 1 over 2 to the power of its division.
3.
Good. And then I have x. I'm dividing. What do I do with the exponents? Subtract. 6 take away 1. And then y. 6 take away 1. Same thing. 5. That's it. But you can actually simplify this. What is negative 1 to the power of 3? It's negative 1 over 2 times negative 1 over 2 times negative 1 over 2, right? That's what that means. I can't simplify my x to the power of 5, y to the power of 5, because I don't know what the variables stand for. But I can simplify this. So what is it? Positive or negative? Negative 1 over 8, x to the power of 5, y to the power of 5. That's the final answer. That's it. So it's 3 to the power of 4, it's x to the power of 2 to the power of 4, and it's y to the power of 3 to the power of 4. What's the first part of this? 3 to the power of 4, so if you want to write it out, right? Because there's an imaginary 1 here. 1 times 4 is 4. And then it's x to the power of 2 to the power of 4 is what? 8. And then it's y to the power of 3 to the power of 4 is, that's it. But you can simplify that. What is 3 to the power of 4? 81, x to the power of 8, y to the power of 12. So what this means is it's at 81 times x to the power of 8 times y to the power of 12. That's what that, that's how you read it. That's the answer. That's it.